The given question is from Control System, chapter Time Domain Analysis, and the given question is for the second order system. If the rise time is 0.6 seconds and the peak time is 0.75 seconds for the response while tracking a input, then the system is undamped or underdamped or critically damped, or fourth option, overdamped. So in order to find this characteristics, we should know the value of eta, which is the damping ratio. By the conditions of eta only we can make out which if the system is undamped or underdamped or critically damped or overdamped. So rise time, which is given as 0.6, and it is having the standard formula pi minus theta by omega d, and the peak value is 0.75, which is already given as 0.75 is equal to pi by omega. This is also standard formula. If you equate both of them in order to find the value of eta, since the standard formula for from the characteristics of the equation, that is theta is equal to cos inverse of eta, so we have to find the value of theta first. So that is, if you equate these two equations and cancel omega d and omega d, and which can also be written, the further simplification which can be written as 1 minus theta by pi is equals to 0.8. Theta value will obtain as 0.2 pi, and as we know the theta value, this is 0.2 pi, we have to find of eta value. So cos inverse can be written as cos theta. So cos theta value is cos of 0.2 pi value, which is nothing but eta value is 0.9. From the conditions of the damping ratio, that is, if eta is equal to 0, then the system is undamped, and when eta is 0 less than eta less than 1, then the system is underdamped, and eta is equal to 1, critically damped, and eta is greater than 1, then the system is overdamped. So we have obtained eta value as 0.9, which will satisfy the second option, since eta is not equal to 0 and not equal to 1, and it is not even greater than 1. So the only option is B, that is underdamped. So from the given data, we found out what is the characteristics of the system. Thank you.